Hello everyone, welcome to Hussain Physics Academy. So today our session is motion in straight line. A ball is dropped from the roof of a tall building and simultaneously another ball is thrown horizontally with some velocity from the same roof. Which ball lands first? Explain your answer. So where two balls are used, one ball is dropped vertically downward, other ball is thrown horizontally. So when the ball is dropped vertically downward, so when it will act as a freely falling body. For freely falling body, initial velocity u is equal to 0. So for second ball, that is horizontally thrown. So at a certain height h. So at a maximum height, vertical component of velocity is always become 0. So it consists of only horizontal component of velocity. So when a ball is thrown at a height horizontally, it is split into two components. One is the Vy vertical component, other one is the Vx horizontal component. So at maximum height, vertical component is always become 0 for any body. So only remains is their horizontal component. But this horizontal component does not affect the motion of the ball and also independent of the time. Okay. So next. So mathematically proof of both the balls are reaching simultaneously. So let us here I am considering case 1 for dropped ball, case 2 for horizontally thrown ball. So consider a ball dropped from the roof of height h. So I am taken as a ball 1. So it is certain height h and time taken by the ball to reach the ground is t1. So here initial velocity u is equal to 0. Why? Because the ball is dropped, so it will act as a freely falling body. For freely falling body, u is equal to 0. So it is falling downward, vertically downward. So gravitational effect there now. So a is equal to g. So time t1. S is equal to ut plus half at square. So substitute here in place of s is equal to h. Why? Because ball is certain height. So u into t1 half gt1 square. So substitute here in place of u is equal to 0. 0 into t1 half gt1 square. Finally we get t1 is equal to root of 2h by g. For horizontally thrown ball, so consider a ball thrown horizontally with velocity u. So when the body is thrown with velocity u from the same roof of the time taken by the ball is t2. So when the ball is thrown with velocity u, it is split into two components, uy and ux. So uy is equal to 0. Why? Because at maximum height, vertical velocity always 0. So always 0. So vx is equal to u. So horizontal component of velocity u, but it will not affect the motion of the ball and independent of time. So this will act as a neutral one. So only we are considering here vertical component. So s is equal to ut plus half at square, h is equal to uy. Only vertical component we are taking here, but it is also 0. uy into t2 plus half gt2 square. So h is equal to 0 into t2 plus half gt2 square. h is equal to half gt2 square. T2 is we finally get root of 2h by g. So this means that T1 is equal to T2. T1 is equal to T2 means both the bars reaches to the ground at a time. Okay, so here two scientists are there. One scientist name is Rick, other scientist name is David Scott. David Scott. So Rick is concluded that here he released one ball horizontally, one ball is vertically downward. So he finally observed that the distinct sound of both balls hitting the ground simultaneously serves as a compelling auditory proof. So he concluded that when both the balls, one ball is released horizontally, one ball is vertically downward. So he observed that both the balls reaches simultaneously at a time and observed sound here also same sound. Okay. So second person is David Scott. So the experiment name is Apollo 15 Moon Experiment. So in a perfect vacuum on the moon. So he done the experiment on the moon. So he used one hammer and one feather. So he standing on the surface of the moon and one hammer is released downward and feather is released horizontally. So unequal proving Galileo by using Galileo principle. So in the absence of air resistance, he proved both are reaching at the same time. Okay, thank you. So this is the today's session.